Welcome back to session 2 of work and energy. Today we will continue from the previous session and so where we have stopped, that is, does the gravitational potential energy of the body depends on the path along which the body is moved? So this is a question. Here it means, for example, if you say that see the case 1, here the ground floor or surface, we can say keep an object here and move this object from point A to a certain distance, point B. Okay, now this is what we call displacement, shortest distance between the starting point and ending point. Okay, it means here you can see the displacement traveled is h, height is h, the body is lifted, okay, from the ground floor or from the surface to a certain height h. So work done in moving the body along the path AB to raise it to a height h. Okay, then that is work done is nothing but W here. W is equal to force into displacement. Is it right? Work done is nothing but force into displacement. So displacement is h and force is m into a. Here a is nothing but acceleration due to gravity, that we will write it as g, mg. So f is equal to mg. Then s is nothing but height. So w is equal to mgh. Now our question is, does the gravitational potential energy of the body depends on the path? So here it is the one path which is moved from the ground surface to the certain height h directly. Now if you see the case 2, here what we are getting, W is equal to, so mgh is nothing but potential energy. Okay, case 2. If you keep the same object which is on the surface and change its position from point A to point B here, and then from point B to point C, so marked as C. Now, and from point C to point D, again from point D to point E. Now mark this point. So we know that work is nothing but force into displacement. So this is the what we'll call to A to B, B to C, C to D, D to E is distance, not displacement. So displacement is from A to E. Is it right? So how much displacement? Up to a certain height is h only. The displacement or traveled by this object is h. So simply note down this: work done in moving the body along the path AE to rise its height h, that is same like as the previous case. You can see here W is equal to F into S, where F is mg, that is mass into acceleration due to gravity, and S is displacement. Is it right? So simply write it as the net displacement from the initial and final position is h only. We will not consider like this one. So from A to B, B to C, that is distance, but the displacement is height. The position of from point A to point E, initial position and final position. The displacement between the initial point and the final point, we call it as displacement. Okay, so here potential energy is W is nothing but PE. So thus work done against gravity is independent of the path along with the body is moved, and it depends only on the initial and final position of the body. So simply we can say that the work done is not depending on the what we call gravity. Okay, and its work done against the gravity is independent here, not depends. So here you can see simply as it changes its position and all, and also no matter, but it matters only with initial point and final point. Okay, if the height traveled by the both in the both cases by the object, if it is same, then the work done is also same. It will never depends on the position, means how it is changing. It will depends on the only initial and final positions, only two positions. Is it clear? Next is one example based on that concept. An object of mass 12 kg. Okay, of mass is how much? 12 kg. At a certain height above the ground, if the potential energy of the object is 480 joules, potential energy is given clearly. Okay, so potential energy is how much? 480 joules. Potential energy is nothing but what? mgh. Find the height at which the object is with respect to the ground. Given, g is given. You know the formula. So first of all, write this given data. G is how much? 10 meter per second square. So basically, we'll consider as g is nothing but acceleration due to gravity is 9.8 meter per second square. Approximately, we'll consider as 10 meter per second square. Okay, so round value always. Even though if this value is not there in the question, consider g is nothing but 10 meter per second square. G value always. Then to find what we need to find here, to find the height, h is equal to potential energy is given, question mark, and then potential energy is mgh. Solution, potential energy is equal to mgh. You know that potential energy is given. Find is height. Height we need to find, h is equal to question mark. Okay, very simple. 12 into mg into height is h. So 12 into 10 is 120. So h is equal to 480 by 120. 0, 0 we can cancel. 48 by 12. 12 4 times. So h is equal to how much? 4 meters. So to find is what we call height, not potential energy. Okay. So what is the answer for height? 4 meters. Thus, the object is at the height of 4 meters, we can say. Question number 2. Find the energy possessed by an object of mass 10 kg when it is at a height of 6 meters above the ground. So simply we are calculating the problem based on the potential energy. Potential energy always depends on the height of the object and mass of object. Here clearly given g is equal to 9.8 meter per second square. If they won't give, please simply consider g is equal to 10 meter per second square. Okay, very simple. Potential energy is equal to mgh. M is given 10 kg. G is given 9.8. Height is given 6. So 60 into 9.8. So approximately if you consider it as 10, then 600. So approximately it comes under 500 and change, 590 something you will get. Is it right? What are the units of energy? So simply you know that in terms of joules. So simply note down here, you can see these are values, given data, and then potential energy is equal to question mark. Potential energy is equal to mgh, and you know the value of m, you know the value of g, and you know the value of h. Substitute this all, then you will get 588 joules. The potential energy is 588 joules. Okay, so very simple. Work and energy. Work done in terms of change, that is kinetic energy. Okay, work done in terms of change means, so it will happen only what we call when a body is in motion. Simple. To find the work done by the force in case of change, that is kinetic energy, we call it as change in kinetic energy. Change in kinetic energy. So it will depends on the mass of the object and the velocity of the object. Okay, very simple. To find the work done by the force in case of change in kinetic energy, simply derive an expression of work done in terms of change in kinetic energy. So derivation is very, very important. Work is equal to force into displacement. We know very well. That equal to F into S. Is it right? That equal to F is nothing but MA. Okay. Whereas F is force, we know very well, MA done. Then S is displacement. So displacement is nothing but how we will get basically V square minus U square by is equal to 2as basically. From that s we will get v square minus u square by 2a. So simple formula. From this we can cancel a and a. Okay, v square minus u square is equal to as actually, and from this we can find it. Then s is equal to v square minus u square by 2a. So equation of motions these are. Okay, from equation of motion. So s is equal to v square minus u square by 2a here. From laws of motion chapter or equation of motion, you can see simply cancel a and a. So m and then v square minus u square by 2a. So simply write 1 by 2 here first. 1 by 2 into m into v square minus u square. So this is what we call kinetic energy. If there is a change in velocity, half mv square basic formula. If initial velocity is 0, then half m into v square is kinetic energy. If initial velocity is there, then half into m into v square minus u square will call. So this is the formula to find the change in kinetic energy. If body is at initially it was at rest, then initial velocity is 0, then final velocity is v, then f of mv square. Then this is a half minus half mu square also we can write. Both are same. Kinetic energy when u is 0. If initial velocity is 0, then kinetic energy is half mv square. If initial velocity is given, then kinetic energy is change in kinetic energy. So change in kinetic energy is half mv square minus half mu square. Is it clear? So when initial velocity is 0, this means u into 0 is always 0. 0 into something is always 0. So this is 0 joules. So the work done is equal to the kinetic energy when an object starts from rest. Okay. So half mv square kinetic energy final minus kinetic energy initial. So thus the work done is equal to change in kinetic energy. Is it clear? So this is very important formula to derive it. Okay, based on the work done, that equal to force into displacement. Force formula is ma, s formula is v square minus u square by 2a. From this, if you cancel a, then you will get this formula. Very simple derivation. Derive an expression of work done in terms of change in kinetic energy. Is it clear? Next is the problem based on that. An object of mass 15 kg is moving with a uniform velocity of 4 meters per second. What is the kinetic energy possessed by the object? Okay. So here clearly given mass is given, velocity, uniform velocity is given. Okay. Simple formula of k is equal to ke is equal to half mv square. M is given, v is given. Substitute in that, then you will get the kinetic energy. So there is no initial velocity here. Okay. Moving with an uniform velocity is given. Mass is equal to 15 kg. V is equal to 4 meters per second. Then kinetic energy is equal to question mark. Kinetic energy is equal to half mv square. Half into mass is 15 and v is 4 square 16. So simply half into 15 into 4 square. 4 square is 16. So simply we can cancel with 2. 2 into 4. 2 times is 8. 8 into 15. 15 8 times. That's the answer. 120 joules. So the kinetic energy of the object is 120 joules. Is it clear? And next is certain force acting on a 20 kg mass changes its velocity from 5 meters to 2 meters per second. Calculate the work done by the force. It's not on the by the what we call by the object. It is by the force on the object actually. A certain force is acting. Simply you know very well. So let me tell you. Here two velocities given. So kinetic energy. Okay. Kinetic energy. Calculate the work done by the force. Half mv square minus half mu square. So here if you take a half into m common, v square minus u square. So half into m is 20 kg into v is 5. Final velocity is 2. Initial velocity is 5. So here it is 2 square minus 5 square. So 2 1 times, 2 10 times, 10 into 2 square is 4 minus 5 square is 25 minus 21. So 10 into minus 21 that equal to minus 210 joules. So it means work is applied in negative direction, means force applied is in reverse direction, work done. If you consider 210 joules, the work done is 210. If negative there means negative work, opposite direction. Is it right? Force brake applied. Velocity is decreased here. So here you can consider final velocity is V, and then to find work done, W is equal to F into S. We know very well. Mg, also we can do F is equal to mg. We know these all things. Kinetic energy also we can say change in kinetic energy. Simply substitute in that, and we'll get this all minus 210 joules. The work done by the force is 210 joules, and the negative sign indicates that applied force is retarding in nature, means deceleration. Force is not here. What we can say, brake applied. Okay, some brake force is applied here. Is it clear? Now, give reason kinetic energy is always positive. Say formula is equal to half mv square. Mass is always positive. And velocity, v can be either positive or negative, but v square is always positive. So what we can say, for example, what is the formula for kinetic energy? Half mv square. We are not talking about change in kinetic energy. We are talking about only kinetic energy. Can we say kinetic energy is always positive? Yes. Why? Because mass will never be negative. So mass is always positive. Can we say minus 5 kg mass? No. Can we say minus 10 kg mass? No. Can we say mass is 5 kg? Yes. So mass is always positive. For example, velocity is negative. If velocity is negative, let me tell you, v is minus 2 meter per second. So v square is what? Minus 2 whole square only, na? Minus into minus is plus, then what you will get? 4 meter per second. So is it positive or negative? Positive. So then what we can say? Half mv square is always positive. So give reason kinetic energy is always positive. For why? Why? Because so if you substitute the value of mass, it's always positive. Velocity, if it is either positive or negative, also no problem. It is always positive. In v square. So kinetic energy exists in only one form, that is positive form. Is it clear? Calculate the work required to stop a car of 1500 kg moving at a velocity 60 kilometers per hour. Very simple. Mass is given, velocity is given. Find the work, kinetic energy, that is work done, work required, energy required here. Okay. So mass of the car is equal to 20 kg. Then initial velocity u is equal to 16 kilometers per hour. Then that equal to meter per second you have to convert here. 5 by 18. So 18, 16, 18 3 times, something is cancelled here. 6 3 times, 6 10 times. Okay. And this is 50 by 3. Final velocity v is how much? To stop means 0. Okay. Then kinetic energy F is equal to mg, we know very well. What is the formula to find the kinetic energy? Half mv square, is it right? Change in kinetic energy. So final velocity, final kinetic energy minus initial kinetic energy, that is half mv square minus half mu square. So half m we can take common, v square minus u square, simply write that. So 0, finally is 0. So simply consider this one negative here, minus half mu square. U is how much? 60. So here we can consider this is 50 by 3 in terms of meter per second, 1500 kg. So simply this is What is the answer here? W is equal to minus something you are getting. Thus, the work done to stop the vehicle or car is how many joules? 2,08,333 joules. This is clear in terms of if kilojoules you want means 208 kilojoules. Okay, very simple. What is the work to be done in to increase the velocity of a car from 30 kilometers to 60 kilometers? Here, velocity is increased. If the mass of the car is 1500 kg, so 30 to 60, very simple. So here kilometers per hour is given, convert into meter per second first, and then multiply with mass. That's fine. Half mv square minus u square. So here 25 by 3 meter per second. Final velocity is 60 kilometers per hour. Then convert into 5 by 18 into 5 by 18 here. Then you'll get same 50 by 3. Then mass is 1500 kg. You know very well, work done is equal to change in kinetic energy. Okay, change in kinetic energy. Kinetic energy is half mv square minus half mu square. Okay. Then final velocity is how much? 50 by 3 minus initial velocity is 25 by 3. So here what we can do, how many times it is? 750 times. So simply write 750 into 20,500, 2,500 by 9. And this is 25 square means 625 by 9. LCM is 9 here. You can subtract it. Then you will get the answer and then simply multiply with this. You get a whole answer. 9 tribal. And then this is 250 times something. 3 times, 250 times, 625 something. And finally you got 1,56,250 joules. Thus work done in to increase the velocity of the car is 1,56,250 joules. Is it clear? Now verification of law of conservation of energy in case of free fall. If an object is falling free, means freely falling down. So we have to verify that law also. So position of object is up to a certain height h. So the object is at a height h from the surface. Okay. Potential energy of the object at A. That is what potential energy is? mgh. We know that in terms of joules. Then kinetic energy. Half mv square. We know that, but it is at rest now at a certain distance. So half mv square. At rest, v is 0. Then kinetic energy is 0. Is it right? Thus, the total energy is potential energy plus kinetic energy. So kinetic energy is 0. Then mgh plus 0, that mgh. So total energy is how much? Total energy at A is mgh. But now object position is changed. Position B. Now, can you guess what is the velocity, kinetic energy here? The object travels a distance x from the top. This is height is distance traveled x. Height is how much now from the ground? H minus x. So then what is potential energy? Potential energy is mgh basically. Instead of h, mgh minus x. Then what about kinetic energy? Now the kinetic energy is not 0. Why? Because initial velocity is not 0. Initial velocity is some v is there. Initial velocity is 0. Maybe final velocity is not 0 here. Is it right? So height of the object at the point position B from the surface of the earth is h minus x. Potential energy of the object at point B is mg into h minus x. Potential at point B is mgh minus mgx. To find the kinetic energy of the object at point B, kinetic energy is equal to half mv square. Okay. So that equal to kinetic energy at point B is half mv square. V is first. Find first V. V square minus u square is equal to 2as basically, or 2gs. Then at certain x, the object travel at a distance x is from the top is x. So v square is equal to u is initially maybe it is 0. and then 2 into acceleration due to gravity, displacement is x. So S is equal to x, 2gx. Okay. So kinetic energy is equal to half mv square. You know the value of m. M is always m. V is, we have to find. V square is equal to 2gx. So m into 2gx. So 2 gets cancelled. Mgx. Kinetic energy is how much? Mgx. What about potential energy? You got just before that mgh plus mgh minus mgx. So plus mgx. Is it right? And finally, you will get cancel both, minus mgx plus mgx. Then total energy is mgh only. So from this, what we can say? To find kinetic energy at point C also, let's find V. Same. When the body is at rest, means when it reaches to point C, that is on ground. So simply, this is the position C. Distance traveled is equal to the height of the object from the point. S is nothing but h now. So V square is equal to, initially it is 0, velocity 2g h. Simply kinetic energy is equal to V square, you got 2g h. Kinetic energy is equal to half mv square. Half mv square. So you know that m is always m. V square is equal to 2gh. So 2 gets cancelled. So 2 gets cancelled. Kinetic energy equal to mgh. What about potential energy? As the height is 0, then potential energy is 0. Finally, kinetic energy is mgh. Now the potential energy at point C is mgh. H is 0. So potential energy is 0. Thus the total energy at point C is potential energy plus kinetic energy, and this is equal to mgh. Total kinetic energy, total energy is mgh. Thus the total energy of the body is constant and is equal to how much? Mgh at any point when it travels from a certain height, from here to the ground, at this point, at this point, at this point, at this point, anywhere, the energy of the body will change or remain same. Is it always constant? Is it clear? So this verifies that the law of conservation of energy. Okay. So law of conservation of energy says that, you can see here, based on the law of conservation of energy. This is one best example. Energy from flowing water. Hydroelectric power plant, this one. Here also you can see that turbines. So high-rise dams are constructed to obstruct the flow of water, basically. And see here. Water at high level contains potential energy, but at low level, no potential energy. Why? Because so we need some height to get the energy, potential energy. If height is 0, potential energy is 0. So here you can see the turbines will start rotating based on this. So water from the high level in dam is carried through the pipes. Thus the potential energy of water changes kinetic energy. So kinetic energy to mechanical energy. So initially these are at rest. So kinetic energy is 0. Now the kinetic energy is there. Why? Because they are in motion. So some energy is there. So that energy is converting into mechanical energy. So kinetic energy is converting into mechanical energy here. So this what we call generator here. Okay, turbines are connected to generator. So mechanical energy to electrical energy later. So what is the purpose of generator? What generator will do? So generator will convert mechanical energy to electrical energy. So what we are doing here, first of all, work done by the water. So that water is converting kinetic energy into mechanical energy. And this generator is doing converting mechanical energy into electrical energy. So here, what is the purpose of this turbine? So turbines are to change the kinetic energy into mechanical energy here, and generator will convert mechanical energy to electrical energy. So here it will transfer in the form of electrical energy. So in the next session, we'll continue with the law of conservation of energy. So you know as well, very well, the energy neither be created nor be destroyed. It changes from one form to another form. Okay, one form to another form. The total amount of energy in the universe always remains constant. You can see here chemical energy, electrical energy it is converting here, light energy, heat energy, electrical power, commercial unit of electrical energy we'll discuss in the next class and define 1 joule. Okay, so we'll continue in the next session. Let me stop here for today, and this is session 2, and continue in the session number 3.